Yo, welcome everybody to this cool stream. Yeah. Today we are writing the Vulkan renderer of my operating system. Whoa. And so I'm gonna show you a little demo I made. So basically, and by the way, don't mind the NCS music. It's a little bit too loud for me, so let's turn it down a bit. I don't even know if you can hear it. Yeah, that said, I wanted to show you a little bit of an example. So we have basically 12,000 yo rose hip. We have 12,000 rects drawn with the Vulkan engine, using XOR shift for randomness, because I don't want like rand, churn and stuff. Now the problem is I don't really have a way to open a terminal. I mean, we can do it like this. So let's go into here and then let's just have the example. I think it's in build. Release bin examples GFW. Okay, so that's cool. And we get like a lot of FPS. Probably the bitrate is fucked. Wait, let me check my OBS bitrate, by the way. Bitrate is 6000. I think that's okay, right? Is that okay? Yeah, I think it's fine. So yeah, that's basically the batch renderer drawing 12,000 instances. And today what I'm going to implement is and by the way, 12,000 is like very minimal. We can also just do 1 million, I guess. Let's try 1 million, shouldn't we? So let's make clean, make build, yeah, basically that. Yeah. So we're going to make a release build, and okay, we get a compile error. Nice. What's the compile error about? Okay. Expected in Vulkan core in core render passing argument pointer without a cast. In 200. Your display source is offset from the top left. Oh. Thank you, man. Oh my god, I love you. Thank you. I'm sorry for that. In image instance version. So I'm passing. Okay. Okay. So I think what we should do is do something like ver ideal would be like the ideal version we want is 1.4, and then we just do this, because I am pretty sure Vulkan expects us to basically give it an API version from VK API version, right? So I think this should work then. W streamer, thank you, man. Haven't heard that song in like 10 years. Phenomenal. Yeah, I know. Okay, YouTube is saying my frame rate is too high, by the way. Please reset the frame rate to 30 FPS or less. I don't like. Okay. No. What? Ich benutze Rust. Okay, so you're using Rust. Yeah, by the way, about the music. It's like, yeah, I don't want to. Oh my fucking bruh. Yeah, that's why this setup is bad. Yeah. You can expect this happening. Oh my fucking god. You can expect this happening multiple times. I don't think W streamer is valid at this point. Wait. Like I'm setting up my phone on my screen. So wait. Yeah. I mean, it won't hold. Oh my god. I mean, I can try that, but I mean, it will fall again. Vulkan speedrun once again. Companies are struggling. I'm sorry, man. Wait. Frame rate too high. Oh no, my streak is too tasty. Steak is too tasty. Yeah, for real. Compressor is struggling. Yeah. Fail to create batch rendering pipelines. Fail to create rendering context. What about that? So we just don't return true, right? Is that the thing? Okay, but I never saw that error. So that's, by the way, that's 1 million instances now. So that's kind of a lot. Oh my god, yeah, it didn't rebuild correctly, but whatever. Like the goal of this stream, it's the simulation too high load. Yeah. The goal of this stream is to basically make the vertex pipeline of this renderer work. Because like the thing is, we can draw rects, but drawing vertices is actually another thing. Because what I eventually want to have is drawing like the vertices for the vector rendering. That is the thing that the engine is supposed to do, right? And for that we should render vertices. So let's try rendering a vertex at 2020 with vec for 1.0, 0.0, 0.0, 1.0. Like that. And then at like 520, 500, 500, and then 20, 500. So let's try that, right? So this would be just a basic quad in vertices. Are you using CGLM? Yeah. Bro, how can I learn graphics programming using C, not C++? I mean, like Vulkan, it works normally in C as well. So you can just include vulkan/vulkan.h and then reference the documentation. Like it's not really a C++ only thing. So let's just have this command, because okay, let's append to that command. And yeah, we're going to build and release. I mean, I think it's okay. So let's do that basically. I don't really like make files. Yeah, is the music too loud? I think the music might be too loud. Yeah, no, I think it's okay. But the music is bass, man. God, I love C. Didn't know Vulkan works in C. Yeah, it's completely independent of language. Segmentation fault. Ah, yeah, that's expected, right? So we're trying to render vertices, but the whole vertex thing is not set up correctly. So let's first start by so I have this create render pipelines thing. And as you can see here, the vertex pipeline input state is correctly get. And then we are creating the vertex pipeline with the default shaders. So shaders default, just a shader that converts the vertex positions to normalized device coordinates. So this part works, right? But the part where we actually create the resources, I think this actually also works. So let's try create GPU buffer. Because like every pipeline has some resources, obviously. Vertex state, yeah, we basically init vertex state, we create a device local GPU buffer that stores all of the vertices in batch group cap. What is batch group cap, man? Batch group cap is this. I think we should call it total vertex cap, right? So that's the first thing. Let's go into batch, because batch group cap is like, what even is that supposed to mean? It was like a legacy thing. I named it like that. Let's just call it total vertices, because the batch state is supposed to store the batch VBO, vertex write offset, total vertices, like the ability to store, like how many. That's basically the capacity. That's the number of vertices, and yeah, then the write offset, and then we can submit the batches to draw with indirect drawing. See my beloved, what the hell is a class? Okay. Any good sources to learn C by doing projects? I think doing projects. Like, I think doing projects is a good source to learn C in itself. Is there any book you can mention for learning that? Bro, like the thing is, I really didn't read any books. I just coded, like retalk. But maybe like on the thumbnail there's this anime girl, and she's holding a book. You could read that book, I guess. Let me check if the thumbnail is there. Yeah, you can read that book. Okay, so let's say the vertex, the total vertices is equal to that, but let's say vertices cap. But then yeah, let's say vertex cap. So this is that, and then in init instance state, right? And here I commented out init vertex state, so we're basically not even initializing the vertex state. So let's just not comment that out. I think this is like a big step already. What NVIM theme is this? Night lamp. Night lamp. Will Rust replace C, C++? Please say in detail. I don't like. I cannot really say about anything about the future, but like what in my feeling, Rust is just a more overbloated C. And I think a lot of people think that way. So I think I don't think Rust is bad. I think the borrow checker and all of this stuff is actually pretty cool. But in certain applications, I mean, languages never really die because the applications just keep on using them, because there's not any worth in switching to another language when it already works in the language it was initially written in. And looking at economics, if you run some system, it doesn't really make sense to spend dollars, like a lot of dollars, on getting devs that know another language just for the sake of rewriting it. So I don't know. I don't really think that languages will just die. Rust is overkill for most things I do. Yeah, my favorite is C++. I also like C++. Yeah. Okay. So we init the vertex state. Now draw vertex. I mean, we can kind of do this and copy a lot of things from draw rect. So what's this draw rect? I mean, we can just copy that basically. So just copy that. Yeah, like the main thing is to integrate that into the indirect pipeline. Because before that I had a pipeline where I just accumulated draw calls and then called all of them at, like, not at once, but every single one after the other one, and this was like not that efficient. Oh my god, that's a banger. That's a banger. And then we just say vertex red offset. So we say the vertex dot vertex red offset batch state dot vertex dot n vertices. So basically the index is just the total actual index, and the write offset is because you have to understand, like, we are storing all of the vertices in all batches in one contiguous device local memory buffer. So meaning that you have like this vertex, then you have this vertex, then you have this vertex, then you have this vertex. So, and then maybe here's a new batch, and you have another vertices set. We're storing all of this in one array, and we don't even know that there are batches. The only thing we do is keep track of the write offset for every indirect draw, so that we can say end of the number of vertices like at the batch's end. But we don't even really need to do that. That's only for the last batch. But still, we do that. So basically, we have this contiguous amount of vertices, but we store just the offset where the batches begin and where they end. This is basically what we're doing. And this is why we have a global offset. And the index is the global offset of the current batch. So basically, if we're at the second batch, this would be here, like here. And then the n vertices in the current batch is like the index in the current batch, basically, right? So then we can advance to here, for example, if it would be 2. And that's basically that. So that's how we get the index for the current vertices we want to append. And yeah, and then we basically just say frame.batchState.vertex. Yeah, and then, yeah, we don't really have any CPU array of vertices. You need to get that. Because like here we have CPU instances. And that's pretty important, right? Oleg, how else would he get information? Ehrlich Zeug ist gut. Wann benötigt es? Okay. But this guy is like, I don't know. Just write in English, man. You as a retalk. I'm not fronting you, but your English, your German is not understandable. Retalk. Each tool is good when it is necessary. Yeah. This is my first time on the stream. What's the overall project about? It's basically about creating a vector rendering engine that outperforms Google's vector rendering engine. I mean, it already does, but it needs to get like more features, and that's like basically the point. Can you make the font smaller? No. Because of the mobile users. So if every mobile user in the chat says the font is too large, then yes, because I would like to make it smaller, but I think on mobile it's actually kind of small. So what I wanted to do is where's our CPU instances here? So yeah, we'll probably need that, and we just do the same thing for CR vertex, CPU vertices. And why do we have the vertices on the CPU side? Good question, but I mean, we kind of need to. I mean, we need to have some kind of handle for them. But what we do is we have in this engine, we have a host coherent ring buffer, which is basically a thing that in Vulkan there are different buffer types. There are device local buffers, and there are like host coherent buffers. And there are also other types, but this is like a device local buffer is, as far as I know, a buffer that only like the GPU can see. And a host coherent buffer is like a buffer that can, that is like coherent to the host, so that we can also see as the host, as the CPU. But just writing into host coherent memory isn't that efficient. Which is why we basically have a device local buffer for the VBO. So when we check that, device local, here. So we basically have a device local buffer for our VBO, and then this gets served the vertex data from the staging buffer that is like host coherent. And we just copy it into the staging buffer, like the vertex data, we just copy the vertex data into the staging buffer. And then from the staging buffer, copy into the device local buffer. So it's like a little bit of a complication, but in the end it's better because then we don't have to stream from PCIe, and we can stream from VRAM. How did you learn Vulkan? I'm like, so you don't quote me on anything I just said because I'm doing Vulkan since like 1 week, and I just learned it for this video I made like 2 days ago, and now I'm rewriting the rendering engine of like my window manager and stuff in Vulkan. So 1 week. And how did you learn? Oh, sorry. I learned Vulkan by reading the documentation, and yeah, and basically I think it's like the documentation is actually really good. So this is not like a read the documentation thing. It's really good. So I really like it. I had moments where I just read the Vulkan documentation in my free time because it's so good. That's a little bit weird, I know, but yeah, it's actually really good. So I think you should read the Vulkan documentation. And also I had this Hello Triangle thing. Here's many examples of that. Turn off a Minecraft Let's Play. Yeah, bro. Sorry, man. Enable. Yeah, this is like a SVG. I don't really know, but it's mainly for drawing the UI of my OS. Yeah. Okay, so basically the point now is to index into CPU vertices at index, and say we want a new struct CR vertex with pause being pause. I think we cannot even do that, right? Oh my god, so dumb. Let's do this. I joined and I liked. Goodbye, there's a riot in our country. That's insane, man. So I don't even know how I'm supposed to respond to that. Bro, I mean, what I'm doing wrong now? Should I do it like this? Oh my god, that's crazy, retard. Color. Does anyone have a way to just assign vec2s normally? Hey, why can I send links? You cannot send links in YouTube chat. Maybe like, I don't know, put spaces in between the slashes or something, I don't know. Hey man, cool NeoVim config, have you shared somewhere that I can... I just... So many people are asking about my NeoVim config, but like literally I'm just using NVChat. Okay, I'm doing a speed run of getting my NeoVim config, okay? So, yeah, I'm probably... Let me quickly open Firefox here. So, NVChat. Install. Okay, wait. Nvim back. Okay, so okay, so start, okay. Done, so that's that. So you know you have this setup, which is literally everything. And then you have this problem with the fonts not working correctly. I don't really know why you have this. But I think that's even it. Like, just use night lamp. Or is it even night lamp? It's not even night lamp. The theme, yeah, I think it's night lamp, I guess. Then go into local. Yeah, I need some kind of... Is the cam still working? Hello, thank you. Let's go into here, yeah, and then just edit this, and it already works. So this is it. This is literally it. And also the font is not bugged out anymore. So it's literally that, just that. And I think my theme was something like mountain? Probably mountain, yeah. And then, yeah, installing the fonts. Power-S, Victor, Mono. Victor. TTF, Victor, Mono, Nerd. That's the font. Then you go into cd.config/alacrity or your like terminal, and then you just paste this bad boy. Then you have the font, and that's it. Like literally, it's not that deep. Facecam for GTA 6 for real. Hi, you pop up on my recommendation, so I don't know much about you. If you don't mind, can you say how much experience in C, C++ you have, what position you work, what pet projects you have or planning? So, how much experience in C, C++? So I think I'm writing in C since like 5 years, and my pet projects are, I guess, a Wayland compositor, this engine here, multiple UI engines, and yeah, stuff like that. And then what position you work? I work as a front-end dev in a company, but I work there only like once a week because I'm going to school. So yeah, I don't really work, really work. And yeah, planning. I mean, I'm planning this project. It's not really done, but planning other projects. Maybe like what I'm actually planning is writing a MP3 decoder. I think it would be a cool video. So I'm looking into that. MP3 decoder and then writing a custom music player in that video. That would be a great video, I guess. Which DS do you use in projects? DS? What is DS? I don't know. I like C as well, it's really good. So-called GFX got a Vulkan backend. Yeah. Cool. But I'm writing the Vulkan backend currently for so-called basically. Yeah, I mean, I think so-called is cool and shit, but the thing is that I think that's what I'm trying to solve, the problem of rendering like an extreme amount of vertices or instances at the same time in real time, like streaming stuff, is a thing that I think I have to solve myself. Good to see people coding by hand. Yes, without AI. Yeah, I guess. Thank you. Bro, we are literally just talking, man. We have to get this going. So n vertices plus, and then this chunky boy is basically the resizing. Basically the resizing, because obviously we need to have a fixed size VBO allocated at the beginning, which is done in here actually. So let's fix that. Total vertex cap. So we are allocating so many vertices. I mean, we cannot allocate infinite vertices. So what should we do? Okay. What should we do when we don't have any space anymore? We should resize the GPU buffer, right? But we're actually not doing that because we are lazily resizing the GPU buffer somewhere else. What we are doing here is just resizing the CPU handle. So let's do that for vertices as well. So vertex. Damn, I wish I was as good as this kid, bro. I don't know, you're a retard. Are you German? Yes. Hi bro, hi. Can you please make a video on your system setup, like setting up your dot files? Yeah. Yeah, maybe. So let's say the total vertex cap CPU is just basically doubled, and we are maxing index and this to not, because what if we, for some reason, what if index grew so much that even double the capacity wouldn't be enough? So we have to max to index, right? People need to realize system dot files or even don't help with your programming skills. So true, man. So true. Make good. Yo. Okay, so that's that, and then we basically reallocate new CPU vertices. So this is actually just very easy at this point. Vertex.cpu vertices and vertex.total vertex cap times size of CR vertex. And when we failed to allocate, then let's say for vertex data, and this is new CPU vertices, and this is vertex CPU vertices. So basically that's that, right? For actually, because draw vertex is just a really easy CPU insert, because that's what it's supposed to be. And then render flush, this is false, because flush instanced. Yeah, but we're going to fix the typos somewhere else. Like in a different stream. So this. For dot file and shit, just get hyperlink dot files on MVChat, just get shit done already for real. In my opinion, it kind of helps. I'm way better in programming when I have proper syntax highlighting configured. Yeah, that's kind of a cope. Like retalk. Okay, so this is already set up. So this is correct. And we handle null. True, thank you. If not frame indirect commands, then we want to say that we error. CR error context.log failed to reallocate indirect command buffer. Like that, and then go to error. Yo. Cool. So we handled null, and now we basically do this, which is kind of dumb because the instance count in this case is actually 0 because we are not rendering instances. So let's say if flush instanced, yeah, instanced, yeah, and then else, and when we don't have an instanced flush, we still want to append a okay, that's also because this is an indexed indirect command. And we don't really want to have indexed indirect commands. So I'm not really sure. Indirect command? Yeah, I think the best thing is just to use the, I don't know if, I think there's even a thing in Vulkan where you can just pass any kind of structure to the indirect like draw call. So where's our indirect draw call? Here. So draw indexed indirect, we can just pass the size of this. And what if we just pass the size of the non-indexed one? I think, yeah, that's just, yeah, I don't know how that's supposed to work. Like, I really don't. Yeah, let's just do it like this. So let's have something like indirect commands instanced, vertex. This is not indexed because we cannot really generate indices in any efficient way when we have arbitrary vertex data. So we're just going to do non-index drawing. Hello, friend, I have a weird question. How old are you? I'm 17. For me, actually, Kitty, Plasma, and Kate as code editor. Yeah. Okay, so let's do that. And then we just say vertex, this is instanced, this is instanced. And then we just say is equal to vk draw indirect commands. So what does it want from me? First vertex and vertex count. So first vertex is frame.batchstate.vertex right offset, and the so that's like basically what I just told earlier with the offset tracking, and vertex count is just going to be the vertex.end vertices. And then we can say instance count. I think we need to provide one, but I'm not really sure. If you don't want instances, a small Vulkan rudder for stop like making vertex buffers. Not really. Like, it's supposed to be a library that actually is able to immediately draw, like in immediate mode, draw vector graphics. So this is like the lower level API drawing vertices, but what I want in the end is something like CR begin path, and basically like it's like nano VG, but better. Just me. So it's not really about making vertex buffers, but making vertex buffers is like internally a thing, but it doesn't expose any of that to you because it's supposed to be a high level API, not a Vulkan API. So that's even theoretically you should be able to use different different rendering backends like OpenGL or Metal. Kind of like GL begin. Yeah, that's basically the thing. I just want the developer to be. That's not correct. Let's say first instance equal to 0. To the developers to be happy, and there's just like have to call very simple stuff to just get things done. And also, I'm the developer, so I'm the client of that library. Like I'm designing it mainly for myself, so for my own applications. And what I just want is a way to correctly do stuff, and basically also to have a replacement for Runara. Because I don't know if you guys know Runara, but it was the old engine that rendered stuff. For example, this is the music player, right? It's rendered with Runara, and also all of the vertex compositor. Oh, all of the vertex compositor. Vortex compositor, by the way. So the Wayland compositor. So that's basically this compositor. Vortex. I don't know if there's currently a build that runs correctly. Oh. No. Yo. I crashed my entire PC because I ran the vertex compositor, vortex compositor on X11. So thank you, nice. I lost all the viewers probably. Yeah, great. I love it. So the thing is that my compositor doesn't really run on X11, and it creates such big problems that my entire PC just shuts down. So it's not like You have to understand, it's not like only awesome crashes, my PC crashes. It would be so good if the stream is still live. Is the stream still live? I have to verify it's me. I don't really want to. Do I have to? Oh my god, why? Wait, let me cook, guys. I'm going to put in the chat in a second. No, why? Please. I don't want to verify. Can I just skip the verification? No. Wait. I'm leaking it all, yeah. But yeah, oh my god, fuck. That's actually crazy. Yeah, that's a problem. Guys, I think this is a problem actually. But I don't think we saw password is 8 circles. Ah, man. Why is my screen recording the wrong screen? That's like not that cool. Wait, so where's screen capture? Why can't I? Here. Okay, so let me unleak myself, please. Yeah. Okay. So I think now we should be good to go. I mean, a little bit of a password leak isn't too bad, I guess. But you can hear me? Okay, nice. Okay, so I have to get the the cam back up and working. So let me quickly do that. All right. So I mean, it's supposed to work actually because the link is still valid. No, yeah, now it works. Or why do I just like what's that supposed to be? Wait, let me quickly set up the cam correctly. Like that. And then like just copy all of the data from the browser widget or like source properties. Yeah, now you can see me again. Okay. Copy that. Put in a new browser source. Do that. Yeah, now we can see myself again. Okay, let's do this. And do that. Okay, nice. And then do a transform center flip horizontal. Yeah. That's my settings, by the way. Yeah, you didn't see my password. It's all good, man. Yeah, even if you did, I mean, okay. Like the at most it'll be 40, which can be done with good hardware. Yeah, man. I mean, you have to understand that we don't live in an era where passwords are a thing. Like, I hate to break it to you, but there is a thing like so like how is it called? Two-factor authentication. Authentication. I can't speak English, I'm sorry. 2FA, yeah. Thank you. Okay, guys. So I think we're back. No, we're not back. We need to get in some NCS music. Some NCS music, right? I love Rust 2025. What the fuck? No. No, please. This is actually my password, man. Okay. So, okay, I think now we're back. Now we're officially back. How people come up with these ideas, the fuck? Yeah. It's not that bad, man. That's okay. So let's actually do the music is kicking at the perfect time. You are genius, man. Okay, gamers, so let's actually. Why is the theme so good? Like, no joke? This is looking really good. Is it because I just installed the new... I think it's because of that. I think we have to get that back, because, yeah. Let's just do .config rf nvim, move nvim back to nvim. And then let's quit, because I don't think the auto reload system will actually work. But it's still looking great. Okay. Wait. So, let's get this out of the way, and okay, nice. Indirect command vertex. Okay, so it was just the autocomplete. Vertex. Okay. Yeah. Okay, this is not such a good track, I guess. Let's put it back at the first. Yeah. Newer Vulkan features or extension. I mean, I'm using multi-draw indirect. I guess that's kind of new. I don't know if you like approve that, but yeah. So let's have this be instanced, this be instanced, this be instanced, this be instanced, and this be instanced. Indirect command capacity. Yeah, this should be still the same, but not really. Oh. Because, like, the capacity is dynamic, which is kind of a problem. Indirect command buffer. No, okay, it's the command capacity of the actual storage buffer. Bro, that makes things so much more complicated, man. Okay, so what I'm probably supposed to do is, like, to make it actually good, is go into the batch state, and we have vertex and instanced states. So we should probably just do this. "17 errors is great, man. Retalk. So frame. Let's just replace indirect frame. Indirect command capacity with frame batch state dot instanced dot indirect command capacity. Actually, indirect command capacity. Okay, so this clears up a lot of errors. And this is then a thing. So when we have instanced indirect commands, we want to do different things than when we have vertex indirect commands. So instance dot is this vim or nvim? It's vim. So n indirect commands, and this is like n indirect commands. Actually not, this is batch state dot instance, and for here as well, batch state dot instance and indirect commands times size of that. And I mean, does anyone know? I don't know if anyone knows, but is it possible to have one indirect command buffer that contains both indexed indirect commands and indirect commands? I'm supposing no, because this doesn't really, it's like really weird, but this would be cool, I guess, because then why do you specify the size of the indirect command you're using? Instanced dot n indirect commands, man. Instance batch the indirect command capacity. Oh, valid. So this is just, but this doesn't really make sense, man. What was that in the beginning? Frame n indirect commands. No, it can't be the case. Frame n indirect commands. Okay, yeah. Actually can be the case. And indirect commands instanced. I thought this was like a global state or like context state. I thought Vulkan already had commands. Why even use indirect commands? So indirect commands are basically instead of like suppose you have 3 draw calls for 3 batches that you need to draw. Like then you would just have something like vk command draw indexed for the first batch, and for the second batch, and for the third batch. And instead of this, with indirect draws, you can just have a GPU buffer that you put data into that is basically explaining the GPU like your draw calls that you want to do, all of your draw calls at once in one buffer, and then you can just call vk command draw indirect and give it your indirect buffer, and it just does it all at once instead of invoking multiple draw calls. So that's very cool. I love that feature. So you batch all your draw calls in a single buffer. Not really a buffer. You basically batch all your draw calls into one draw call. Right? But like yeah, it's a buffer. So yeah, I mean you pass it into a buffer, and then this buffer contains all of your draw call data that is then going to be all executed at once. So yeah, it's yeah. Indirect commands instanced and an indirect commands instanced. Indirect commands. Okay, yeah. But is this frame thing? Pretty sure that's not a frame thing, it's a batch state thing. So yeah, here. Indirect command buff. Okay. So we basically want instanced. So batch state, instanced, command field. I'm doing 3D right now. When I make the Vulkan backend, I definitely use this. Thank you so much. It's so great. Like, it's the best info I've ever gotten in Vulkan. Because I was always like, draw call count? How do I reduce it? Fucking draw indirect. And every problem with that is solved. That's like literally really cool. Okay, so this is basically the drawing now. So this is when total instances is less than 0, then we want the indirect command buff.buff but instanced, and this is like in the batch state now, so batch state.instanced. And n indirect commands batch state.instanced .n indirect commands. But I think it's actually like this is a little bit bad design. We definitely have to rewrite that, but it's like a proof of concept in the current like what we're currently doing is just like try to get it working and then fix it up later. So yeah, we alloc the instance thing we alloc basically the buffer to store our instanced draw calls in. And yeah, then this is this, right? So instanced. And this is like batch state.instanced. And then we just need to do the same thing. We need to do the same thing. But what I currently... Okay, so this is already the case. Okay, that's great. So basically copy that. And let's just basically replace instanced with vertex. Okay, yeah, that works. And then that actually works already perfectly. Should work perfectly fine. So instance and vertex state allocated. Yeah, and then we just need to do the vertex draw pass, and that's it. As far as I can think. So basically total instances is this thing. What's your near room config? Like, I get the question like a lot. But I like even I did a speed run on this stream, where I installed my NeoVim config, so you can go back to this. But it's just literally NVChat, like literally just NVChat. Because like people always think I like modded NVim and stuff like that. It's just NVChat. Is this DWL? This is currently awesome, actually. Yeah, because I like my Wayland compositor isn't yet ready to stream stuff. Put it in stream description. Yeah, for real. Yeah, I can't really open my stream description right now because my YouTube layout is kind of bugged. Yeah, it's bugged out, like, as shit. Okay, but now this the chat is off, like, as shit. Yeah. Wait, I need to actually put that in the stream description, because... Can't I edit the stream description while I'm live? That's insane, man. I think I can't. Stream settings? Ah, I can. Edit description. So nvim config, man. Nvim config. Let's put in the NVChat link. Okay. Can you confirm that the link is there now? It would be cool. Would be actually cool. What operating system is that? It's Arch Linux, man. So total vertices. So vertex dot vertex right offset. Nice, thank you, man. That's good. So okay, so let's do vertex dot n vertices. Those are the total vertices, and then we have this part, and then like, okay, Yeah, but this should work. I think it should work actually very nicely. So this is basically the uploading part, right? So this is the part where we use our staging ring to correctly upload the CPU side data to the GPU. No way, i3. Like, why? I mean, no, it's awesome, man. I mean, yeah. It's not i3 actually. But I think tiling window managers kind of look samey, I guess. So total vertices, this is going to be false. And total vertices, vertex, total vertex cap. Vertex to total vertex cap. Ah, by the way, guys, very important. Because I have a video planned for the other channel. Yes, the channel exists. In one video I announced that I am starting a new channel because this channel isn't monetized, as many of you probably know. So basically the channel here, it got demonetized because I posted a private video that contained a quote from a person that I'm not going to mention, because then I think the stream is going to be demonetized. And it's not a very bad, like a very bad person, right? So it's like really insane. I don't know why, but this channel is demonetized. I can't do anything about it. So please sub to that channel. Okay. But what a nice project, man. I'm so excited to see the final product. Yeah, I'm also very excited. So go into the description, guys, and sub to the channel. Would be great. That's all of the advertisement I'm going to do in the stream. I promise. Day 1 of making my Season 2, bro. No. Do you also do C++? What do you think about it? Yeah, I do C++ in some projects. I think it's cool. So, total vertex cap, total vertices. And then we need to also resize the actual, like this is the resizing of the actual, because in draw vertex I said we are lazily resizing the GPU buffer. This is what I meant, because here we are just reallocating the CPU buffer when we exceed the capacity. And this is why we have a separate capacity that is not CPU side. And then we also resize the GPU side buffer. Right. So that's basically resizing the device local buffer. Yeah, a lot of people hating on C++. No, C++ bad for real. Which OS are you using? Using Arch? Linux. And C++ is not really bad, no. How to be this god? Yeah, I mentioned these things like 10 times a stream or something. So batch state dot vertex dot VBO vertex dot total vertex cap. I mean, I can't really use a find replace in here because vertices, vertex, stuff like that, you know what I mean. And then we basically upload to the CPU vertices. So basically upload the CPU vertices to the VBO. So very easy, actually. It's really straightforward. We just have to copy the whole pipeline. That's basically that. But having, like, after this actually works, we're going to do it like good. And kind of abstract away a lot of things, because now it's like kind of a mess. So this is our instanced thing. We also need to do the same for vertex. So instanced vertex, I think here we can do a find replace, but it's without the percentage. And yeah, then we have to do draw indirect. Okay. Do people actually need sys-level programming devs, like, for a job? Yes, I guess. Like, why wouldn't they? The question is, do guys actually need web developers or front-end, like, high-level developers at this point? I think this is more the question. How do you render the vector graphics? Do you create mesh to draw it, or do you rasterize to a texture? The approach that I'm going to be using is, first step is going to be path data, right? So path data input from the user. And this will convert to simple edge data with just vertices that are basically like very small quads of the edges of your path data. And this conversion will happen in a compute shader. I like when I'm explaining things like that, I think I should actually draw it out. I think this is like the modern way of how streamers do it. So I think it's actually worth drawing out because it's actually pretty important for myself as well. So let's do that, man. Very interesting. Drawing, yay! Let me please not flashbang you, I'm sorry. Like, you're flashbanged, I know, but I'm going to fix that. Or not, I guess. Can I create a new layer and just draw on top of it? Yeah. Okay, and then this thing should be in white. What I'm trying to say is, yeah. So basically you get path data, like for example, you have a line from here to here, from here to here, from here to here. And this is like you just want to draw a triangle as a vector shape. And what we want to do is create vertices that create this very small rectangle. So we want to create those vertices. We're probably going to use the index buffer for that. So that we just have this vertex, this vertex, this vertex, this vertex. Then we're going to do the same for this, and then for this. So what the fuck, why are you doing that? It's actually insane, because this will be done in compute, right? In a compute shader. And this vertex data is then passed to the stencil buffer. And with, we're basically exploiting, like this is what NanoVG also does, I kind of got inspiration from them. They are exploiting the stencil buffer for all of the bounce checks. Or not the bounce checks, but the winding order checks. Because when you're drawing vector shapes in a raster, what you would try to do, check for every pixel, is the pixel inside or outside the shape? And this is like kind of, like you can do some counting. For example, you take this pixel and you check to the right, how many edge intersections do you have? And if the number is odd, then it's inside, and if it's even, it's outside. And that's basically the even odd rule and stuff. And you can implement that, but it's really dumb to implement. Because the rasterizer of the GPU also implements that. So you can just use that by using the stencil buffer, because this is like the vector of how you can use that, like a way of using that. So we use the stencil buffer, give it this data, and say it should fill only the things that end up being inside of the winding order fill. So inside of basically this. So basically inside of the area that we closed up with those quads, because it checks, okay, this area is closed up, so we will fill it with the winding order. And this is basically the thing, because then we already have that. And this is for a simple triangle, it's easy. But what if we have holes or something that also does that? Even self-intersections, like if you have weird things like self-intersecting geometry, and it doesn't matter what geometry. As soon as you have any way of generating those lines, like those very small quads, like this, you can just use the stencil buffer and let it do all the work. This is what we're going to be doing. And it's the most efficient way, real talk. Also, like, when you have Bezier curves and you have to tessellate them, we're going to do that all in compute for efficiency. That have it for free, yeah, I know, but they're not as good. No, because I want to learn it, that's why. You can check bro code, he has very nice C course. How much time would you take me to learn graphic programming if I know the basics in C? I don't know, like, not that long. Because, like, I learned Vulkan in, like, the last week. Like, literally, I'm doing it since the last week. And OpenGL is even simpler. So, I don't really know. Like, I think learning the basics... So you're talking about the basics. That's why I'm thinking it's really, you can do it in a week, basically. If you actually put the time into it. For real, yes. Like, I think not 5 to 6 months, no. Like, not the basics, man. Like, come on, bro. The basics? What's your age? I'm 17. So I think you now know, like, my way of how I want to actually do the rendering. Render uploads to device local GPU buffer. Yes. Okay, so we do this, yeah. Then we begin the render pass. We have those render buffers. This is like the instanced drawing now. So let's have... Alright, I will switch to Arch Linux next month and start learning Vulkan. This is awesome, man. This sounds like a really great, like... how do you say, like a thing that you want to do for the year? Like, I don't know the English word, but I think you know what I mean. Like the New Year resolution, yeah. Okay. So let's have total vertices actually. So total vertices. Okay, let's just try a fucking find replace this time. Vertex. Okay, that's great. So vertex static. So we only need to bind. We only need to bind one buffer, one vertex buffer, and this is just the VBO because we're just sourcing from one vertex buffer. By the way, is my microphone too loud? Could be that my microphone is too loud. Okay. So some feedback on that would be great. I just totally worth it. I think I already read that. I have dementia or something. EFK Visual Studio and that MVC. Okay, sounds good. No worries. Sound is good. Thank you, man. Okay, binding the index. We also don't need a index buffer. So let's just. This is actually pretty easy. So draw indirect. We give it a command buffer. We give it the offsets. Or what is this? We give it the buffer we actually want to draw from. So yeah, that's true. Then the draw count. No, that's the offset. Okay. Draw count will be n indirect commands vertex. Sorry. What the thing is CUDA like running on GPU? Clang D. I really don't know what you're talking about, but it's the stride. Oh my god! Now I get it. Now I get the lore. We actually specified the stride. But that's okay. Yeah, but still, that doesn't mean that we can use one buffer. Indirect commands vertex. Okay. I think we're good to go. Render buff, VBO offsets. We bind the vertex buffer and we say total vertices actually. Show specs of your device. I'm using... Yeah. I mean, I'm using the... I don't know how I should do that. I'm using this graphics card. This graphics card. This processor. And 16 gigs of RAM, man. Yeah. NeoFetch. I don't think... Okay, I have NeoFetch. Okay, this was a picture. It's good that it's not there because it has to do... Okay, maybe even... Yeah, let's not talk about it. But I think... Yeah, we don't see anything, right? That's the point. We see... What the fuck is this? Is this supposed to be my fucking screen? Or who cares about my monitor? Yeah, I have a little bit of a weird NeoFetch installed. Yeah. Yeah, I know. I know. Okay. So let's try and go into CPU instances, because I feel like we kind of need that for the vertices as well. Like, we definitely need that for the vertices, by the way. Static instance state. No, init vertex state, please. Okay, so let's just have a find replace. And this is CPU vertices. Hi gang! Welcome gang, man. So bash state.vertex, the total vertex cap. Vertex CPU vertices. Okay, so okay. I mean, it's supposed to work, right? So let's try that. But I mean, okay, I mean, let's go over the initialization process. So let's see, where do we call init vertex state? Here. So this should be called correctly. We also correctly init the indirect commands for the vertex state. Okay. We set the capacity, but only for instanced. That's not good. Okay, so that's just drop your... Bro. Okay. I'm not... like... Just look in the description, okay? Look in the description, man. It's okay, it's okay. Just the description, man. Okay. Yeah, so that's one bug fixed already. Yeah, got it, thanks. Perfect, man. Make video on art shader by... What do you mean by that? Explain. Total vertex cap. Do we set that? Yeah, we set that, I think. CPU vertices is total vertex cap, okay. And then draw vertex is doing this. Yeah. Seems fine, right? Okay, so let's check flush. So skip render, when okay, let's see, instance resize. Okay, we don't have a vertex resize. That's bad. So it's kind of dumb that we need to copy everything. Let's fix that in a moment. But first we copy everything, right? So instanced is vertex. Arch Linux you're using, how do you do that? Make video on that. Just look at Luke Smith, his video, or just type in Arch install when you install Arch Linux. It's really easy because Arch install is pre-installed, and you can just, if you don't want this setup thing, you just type in Arch install. Just that. And it like guides you through everything. You know? So I think it's not really a thing where it would make sense if I have a separate video on that. I mean, if the channel would be monetized, I mean, I take the clicks, but yeah. Indirect command capacity, factory equates. Yeah. Cool, man. Kali is also cool. Yeah. I just tried to like think about how we would abstract away all of the things that we just copy, all of the pipeline state things. We definitely have to do that. But let's try and build, right? I mean, let's just try and build, you know. From where did you learn C? I learned C from doing projects. I remember the first thing, like the first coriander. No, that's crazy. That's actually crazy. Why is there no such? What I wanted to say, I don't need to. What I wanted to say is I learned C by learning C++ with the Cherno series where he made a game engine. Then I switched to C because I thought C is less bloated and I didn't really like C++ anyway. And then I switched to C, and then I just had all of the experience from C++, and I just had to get a little bit more of the C stuff figured out. But from that C++ base, I really easily made the jump to C. Or like the backwards jump, I guess. Wait, are you linking with std C++? Yes, because of VMA. So what's your problem? Did it just fail or? I don't really get it. From when did you start? Wait, bin examples glfw. Oh my god, I'm so dumb, man. It's the wrong folder. It's the old build. I'm so dumb, retard. I started when I was like 9 years old, but then I used to write Java. Okay, look at this. We get nothing. Nice DWM, it's not DWM. Bro, I'm sorry, but it's not DWM. Like, it really isn't DWM. Okay, so we get nothing. Why do we get nothing? I know why we get nothing. Like, I would know, because the thing is... Yeah. So the thing is that we did vertices in an index way, right? Nine years old, goddamn, holy yeah, bro. I'm 17. I'm just 17, so like I coded, like that's insane. I coded almost half of my lifetime. That's crazy, man. Yeah, man. So I think what we definitely have to do, I don't think it's the bug, but what we definitely have to do is have the separate triangles, right? Because we don't have an index buffer. Let me make the chat bigger, man. What is it then? It looks cool. I thought it was DWM. So it's actually awesome. That's my point. Like, like awesome. You know, it's like, hey, another window manager. Like, if you don't know awesome, yeah, then I mean that makes sense. It's another window manager. I was eating poop at the age of 9, bro. Yeah. I mean, I did Java games, bro. 500, 500, then 2500, and then we won 2020 again. Okay, when this works, then I mean, really cool. No, it doesn't. What a surprise. Okay, so draw a vertex. Let's actually debug if n total vertices. Where's total vertices? Okay, so we want to debug printf drawing vertices. Okay, so drawing vertices, and it's basically total vertices. Okay, gamers, because like vertices is very gaming oriented and stuff like that. 500. Why? Like, retalk, why? Why? It doesn't even make sense. So how many vertices are we drawing? Drawing 6 vertices. Okay. Make a tutorial on C programming. Yeah, I don't really know. Okay, that's a problem. We definitely need vertex.n vertices. So that's definitely a problem. That's also a so vertex.total vertex cap CPU. Draw vertex. Okay. And printf. I have a Discord server, but it's not really actively maintained. And I don't really know how I get an inviting. Like, the things I don't use Discord, and I think it's a problem when I don't use Discord and have a Discord server. Yeah, I can try getting the link. Wait, I don't even know if I'm logged in into Discord. How do I do the invite link? Ah, okay. Here. Yeah, I got it, man. So we resize and then we upload to device local CPU buffer the CPU vertices. Thank you so much. No problem, man. And indirect commands instanced. I have the feeling that it could be the case in Flush. Okay, so when we don't flush instance, we correctly do that. I need to look up if I have to say instance count. Instance count is number of instances to draw. The primitives are draw and instant count times. Okay, that makes sense. That's what we actually specified. The vertex right offset and n vertices is vertex count. Yeah, I guess it makes sense, right? And so we do this, right? And then we check this in here. And we upload to the correct buffer indirect commands vertex and indirect commands vertex, size of indirect commands. So we do this totally correct. Okay, that's really dumb. Why do we do this, man? Okay, so we bind the vertex buffer being this vertex buffer, and then we set the dynamic state to the instance pipeline. Okay. Yeah. And then, do we reset n vertices equal to 0 correctly? You're listening to that music too? Yeah, I'm listening to that music too. Like not really in my free time, I guess, but currently, yes. N pending draws, man. That's really legacy code. That's deprecated, man. W music, thank you. Okay, let's try rendering our 6 vertices now. Okay, password. Come, the job. Okay, yeah. Also, my camera just my camera just falls on the job. Bro, I'm at this point. Do I even want to stand up, getting the camera back fixed? Well, this would be a good clip. If it were like Twitch, or I don't know if you can do YouTube clips. Fade to resize CPU. Okay, rage bait, so true. Wait, I will fix the camera. Peak rage bait moment, man. Oh my god, man, the entire setup just broke with all my charging cable and shit. Wait, so also this, my wooden tool, bro. I'm using this wooden thing on my monitor and then like just putting my phone there. That's basically how I roll. So like that. I know I should probably have a webcam or something. Like this is like really insane. I know. This. Alright. No. Getting a fucking psychosis. The voices. shit like that. Thank you. Okay. Trying to get it right. Yeah. Okay. Nice window. Thank you, man. Really appreciate it. Really appreciate it. Let's check if the camera is set up correctly. We don't see anything. We actually don't see anything. Peak. Imagine using JavaScript. Yeah, imagine, right? Oh my god. I hate my fucking phone and my camera and everything. Your microphone disconnected? Does it... What the fuck? Professional streamer, by the way. Professional streamer. And stuff like that. Say. Oh my god, man. Yeah. What the fuck? At this point, no. I'm not doing that. Failed to reconnect your microphone, okay. Okay, one last try. One last try, guys. So getting this like that, just flipping the camera like this. Oh. And doing that. Do that here. Like this. And then it should work. Table a bit. Yeah, perfect. Yeah. Oh, it's holding, I guess. Is it? Oh, it's having a hard time. Oh, just put it somewhere around your keyboard for now. Yeah. Oh my god, the camera arc is insane. I have the feeling you cannot see me correctly, but whatever. It has to be enough. Welcome. But I don't want this Freya Homer message, but if I click on it, then a video starts. So I don't really know what to do. Ah, okay, wait. What if... Ah, okay, it just crashed, okay. So, fail to resize CPU buffer. Wait, what? Draw vertex. Okay, interesting. So index is the vertex right offset plus the n vertices, and total vertex cap CPU. It's probably not assigned. No. And total instance cap CPU. Okay. So let's just do this, and basically for now we copy all of it, okay guys? Vertex.total vertex cap. Bro, this song is very peak. Do you agree, guys? I think you agree. Initial batch capacity and max batch, but what we want to do is ×3 actually. Because we always need multiples of 3, because we are drawing triangles in the vertex path. So that makes sense, I guess. Is a 60% keyboard enough for coding? I think so. But it's not like I think you need at least a 75% to make it really like enjoyable, because I hate it when I don't have the arrow keys, you know? So I think 75% is like the least, like the minimum. Okay. I am back, Penguin Operator. Thank you, man. Welcome. Okay, so let's do this. Later, but try running any C++ program directly on GPU instead of CPU. That's not a thing. But still, you can run programs on GPU, it's always very cool. Let's fucking go, guys. What the fuck? Why is it so... No, what the fuck is happening? No. I think we are leaking a lot of memory. I need to... Bro, my PC... my PC had a really hard time. Wait. Bro, I hate my... Why was it a nightmare? Because I need my arrow keys to do stuff, you know? Yeah. Ah, bruh. Somewhere else said that, but it's also a nightmare for me, man. Okay, so basically we had some kind of problem with leaking memory, I guess. So I don't know if that's actually the case. Yeah. Probably we're doing some resizing all the time. Like it looked like that. So let's try and debug that by doing the most obvious thing and trying to just log when we resize a GPU buffer. Ah, yeah, we can enable tracing. That's also a great thing. Just go into examples, GLFW, and in here we can just say log verbose is equal to true. Bind fn plus WSD. Yeah, I know. I also did that. But still, I am really like used to errors. So it was a nightmare. So let's see. It doesn't resize CPU. Let's actually do btop on that. I don't know. How will the program be called? Oh wait, so Ragnar core render, cdef, Ragnar core render. Build, release, bin, examples, GFW. Okay. So GFW 112, 31% CPU. What? Yeah, so something is going really wrong. I mean, okay, let's try confirm. See, I mean, it could be like normal, because what we're actually doing is we don't do any V-syncing and we just fire the GPU and CPU. Yeah, it's really CPU intensive, man. I forgot, man, I forgot. And also a red square. I mean, blue squares are like, they're okay. They're like good to go, but red squares, man, they really crunch on the CPU, man. Ah, perfect. Thank you. No. I'm just no. From now on, no. I'm not doing that anymore. Man, this is like the biggest rage bait of all time. Let me just do a. Yeah, I'm just going to. We're going to leave the camera, okay? I mean, we're already 1 hour and 64 in, so we're just going to leave the camera. I mean, that's what you get, right? For rage baiting. Oh, that's okay. Let's try that. See how CPU intensive that is. So the instance pipeline. And please don't tell me that the instance pipeline doesn't work anymore now. Okay, it's just CPU intensive, right? Because we are like literally firing over 10,000 FPS. So it really makes sense, like actually. But I still don't get why the resize was buggy. Audience overflow on camera. For real. So why is the resizing bugged out, man? Are we printing stuff? Weird stuff or something? So okay. Let me check if the resizing only is like bugged out in vertex mode. Are you using DWM? No, I'm using awesome. Why is everyone thinking this is DWM? So why is the resizing a little bit bugged? I'm not really sure what, like it's not really bugged. I mean, we can try checking if it's our fault, because like when I resize off stream, it's like ultra clean, you know? And I just noticed that now. You know what I mean? Yeah. So that's basically that. So let's try and drawing 1000 quads and see if it crashes my PC or something. Easy. Okay, but the resizing is like a little bugged, you know? Okay, now let's try doing the same, but with the vertex pipeline. Okay, so I don't know why the resizing has this problem. I think it's actually because we are streaming and resizing in one. Yeah, I think resizing is pretty. But I really don't know why actually. I mean, I can cope that it's because of the stream, but I don't really think so. And even if it was, it would just mean that my resizing performance is ass. Yeah. So let's do 20, 60. No. 2020. And this will be the color. And I have a good idea. We just let's generate 2 random colors. Okay, so 80. This is going to be 8080. And let's create a new color. Color 2. Like that. So we're drawing those, and we're drawing then 8080 and 2080. Like this. 2020, 20. No, let's do this. 8020, 8080, 8080, 8020, 2020. This is going to be color 2. So this is going to be a real test for our vertex pipeline. So let's try that. What Vim color scheme are you using? Looks cool. Oh, cool. Do you see our vertex pipeline? Ah, yeah, bro, we're dumb. We're just trying all of them in the same position. I'm using mountain. It's called mountain. Okay, so I don't really get why it's only one triangle, but okay. 80-80, 80-20, and 20-20. 80-80, 80-20, and 20-20. This is a valid triangle, and I don't know why it's not there. Maybe it's because of the color or something? I really don't know why, man. No idea. Thank you for this amazing stream. You're welcome, man. You're really welcome. Okay, so let's try just drawing this once, because it might be a problem with the batching. Let's just have color be generated like that once for now, quickly. And let's have this. Okay. So that's weird, right? 20-20, 80-20, 80-80, 80-80, 80-80. Okay, that really doesn't make sense, man. 80-80. This is then going to be 20-80. And this is 20-20 then. Yeah, now we get a rect. Okay, so let's have this be color 2, and then let's copy that, do a bunch of undos, put that back, and have this. Okay, gamers, let's see what will happen. Yeah, makes sense, right? So let's now let's have something like u30 size equal to 40, and then we just do x, y, x plus size, y, x plus size and y plus size, x plus size, y plus size, and x and y plus size and xy. Okay, so let's try that. Yo! Yo, yo, yo! Okay, let's see the FPS with that runs. Actually, FPS? Bro, how am I supposed to? Do I just do GFW get time and then should we implement the FPS thing? Yeah, let's just do it. Okay, so getting FPS. I think what we just want to do in begin, I think it's really easy. We just do float current time is equal to GFW get time, and then delta is equal to current time minus last time, delta time, and then we have something like static float last time is equal to 0, delta time is equal to 0. And what the fuck, where are we? Here. And then we say last time is equal to current time. Not current exception, man. We are not in C++, actually. Don't need exception included. So, delta time. Why do make clean every time? I make clean every time because make is retarded. Because, sorry for that word. But the thing is, when you make examples, okay, but like I don't really know what the problem is. I think the problem is even like fixed, because like okay, let's say I would try to change something like that here. Okay, it's actually remaking. Okay, then. Like, what I had, basically, was that examples didn't depend on the engine, stuff like this, and this just... I just thought, like... Yeah, let's just clean every time. But I think it's even another reason, I don't even know. But it doesn't really make sense, you are right. So, let's print FPS. Okay. FPS is infinite. Okay, also interesting. Delta time is equal to current time is equal to last time. Okay. Very interesting. Still infinite. Is that make again? Because like this wouldn't really make sense. So delta time is equal to current time minus last time. And then like last time is equal to current time, right? I guess. What? No. Am I just really dumb? No, I'm not really dumb. It's make. Why? Why are you doing this? I don't know. Probably my make file is just very bad, but it's not really bad, I guess. So we're hitting about 10,000 FPS. So I think this is really peak performance. Even though it's like, oh my god, that's so perfect. No, we're not writing any line of code anymore in this stream. I think we, yeah, like the goal is reached. We can now draw with the vertex pipeline. Which is going to be enabling us actually drawing vector graphics. I think I'm going to be streaming the vector graphics thing. We're going to implement that and stuff like that and fix all of the things. I might be streaming later again, but I definitely have to do a small break, get my things done, eat, stuff like that, you know? Oh my god, we can stop at 2 hours with 2,000 lines, because this would be great. So 9 seconds left. Guys, really thank you for the stream. It was great stream.